Problem number 14, we have g as a function defined to be 2x to the fourth minus 8x cubed minus 1. Our first task is to determine on what interval or intervals g is decreasing. And it says give a reason for your answer, which means we need to show our work and support our value that we come up with. So a function is decreasing when its derivative is negative. Therefore, we need g prime. So step one is to get the derivative. 2x to the fourth derives to 8x cubed. And then 8/3 is a coefficient, so it will move down into the derivative. We're going to multiply that by 3x squared, which is the derivative of x cubed. So the 3's are going to cancel each other out. This 3 will cancel out with the 3 that moves down, leaving us with just 8x squared. 1 derives to 0, so our derivative is 8x cubed minus 8x squared. Now that we have our derivative, we need to find our critical numbers. Those occur when the derivative is equal to 0 or does not exist, but this is a polynomial, so the derivative will always exist. It's just a matter of when this derivative is equal to 0. So we want to factor out a common expression. We see that both terms have an 8, and both terms also have an x squared. So we can pull 8x squared out, and that leaves us with x minus 1. Now we cover them up one at a time. We see that x could be 1, or x could be 0. So our two critical numbers are those values. So if we place those two numbers on the number line, 0 and 1, when we plug in a negative value representing this area over here, say negative 1, negative 1 squared is positive. Negative 1 minus 1 is negative 2. That's a negative. A positive times a negative is a negative. Now I pick a number like a half, which is between 0 and 1. A half squared is a positive. A half minus 1 is a negative. So this function is also negative from 0 to 1. Now I pick a number bigger than 1, say 2. 2 squared is positive. 2 minus 1 is positive. Positive times a positive is a positive. So we have a function which is negative, or derivative rather, which is negative before 0, negative between 0 and 1, and then positive afterwards. We're interested when the function is decreasing, and that occurs when the derivative is negative. So this is our region right there. So we're going to say negative infinity to 1. All right, because g prime is negative. For part B, on what interval or intervals is g concave up? Concavity deals with the second derivative, so we need g double prime of x. And when we plug in the second derivative, when we solve for the second derivative, the derivative of 8x cubed is 24x squared, and the derivative of 8x squared will be 16x, and that's equal to 0. Just like before, to find our possible points of inflection. These two terms have an 8x in common, so we can factor that out. That leaves us with 3x from the first term. 24x squared divided by 8x is 3x. 16x divided by 8x is 2. That's equal to 0. Cover them up one at a time. This tells us that x is 0. This tells us that 3x minus 2 is 0, so 3x is 2, and x is equal to 2/3. So we have x equal to 0 and 2/3. Those are our possible points of inflection because those are the two values of x in which g double prime is equal to 0. So we throw those two values on the number line. We're interested when the function is concave up. That's when the second derivative is positive. So when we do our plus minus chart, we're going to focus on the areas where we get a plus sign. Let's start with a value which is less than 0, say negative 1. 8 times negative 1 is a negative. Negative 3 minus 2 is a negative. Negative times a negative is a positive. Now I pick a number between 0 and 2/3. Let's just go with 1/3. 8 times a third is a positive value. 3 times a third is 1. 1 minus 2 is negative 1. So we have a positive times a negative, which is a negative. And now a number bigger than 2/3, let's choose 1. 8 times 1 is positive. 3 minus 2 is positive. Positive times a positive is a positive. We're interested in the functions, the intervals when g is concave up, which we said a moment ago is where the second derivative is positive, which would be prior to 0, and after 2/3. So we have negative infinity to 0, and you must use parentheses here, as well as 2/3 to infinity. And again, give a reason for your answer. So the reason for our answer here is because g double prime is positive.